Welcome. You have nothing to do right now, nowhere to be, nothing to remember. Simply let your body soften into wherever you are resting and allow your breath to slow. Tonight we drift together through the quiet dark of our solar system, through the vast, unhurried distances between worlds. Let each word carry you a little further from the day and a little deeper into rest. At the very heart of our solar system, the Sun holds all 8 planets in its gentle gravitational embrace. Every planet, every moon, every drifting grain of dust moves in response to this one great anchor. The Sun's gravity reaches outward across billions of kilometers, curving the paths of worlds into long, looping orbits. It is a quiet force, invisible, patient, and immense. Everything in our solar family belongs to it, turning slowly in the dark around that distant, warm light. Mercury is the closest planet to the Sun. Of all 8 worlds, it is Mercury that traces its path nearest to that great golden light, circling in close where the solar wind is strongest and the sunlight most intense. From Mercury's surface, the Sun would appear nearly 3 times larger than it does from Earth, a blazing presence filling a black, airless sky. Yet despite this closeness, Mercury is a small, quiet world, ancient and still, holding its place faithfully near the center of everything. Mercury orbits the Sun in just 88 Earth days. Where Earth takes a full year to complete one great loop around the Sun, Mercury rushes through its orbit in less than 3 months. It moves with quiet speed, tracing a tight ellipse through the inner solar system, year after year without pause. From our perspective on Earth, Mercury appears and disappears near the horizon at dawn and dusk, a brief flickering light. Its year is short, but it has completed countless millions of them across the long age of the solar system. Mercury has the most eccentric orbit of the 8 planets. While most planets travel in paths that are nearly circular, Mercury's orbit is noticeably stretched, an ellipse that brings it much closer to the Sun at some times and carries it farther away at others. At its nearest, Mercury comes within about 46 million kilometers of the Sun. At its farthest, it drifts out to nearly 70 million kilometers. This gentle wobble in its path gives Mercury a quiet rhythm of closeness and distance, drawing near and then slowly pulling away. Mercury's surface temperature swings from -180 to 430 degrees Celsius. Few places in the solar system experience such extremes. On the sunlit side, the surface bakes in fierce heat, rocks glowing with absorbed radiation. On the night side, without any air to hold the warmth, temperatures plunge to a deep, silent cold. These are not gradual changes. They happen across a stark boundary where sunlight ends and shadow begins. Mercury holds both extremes at once, a world of fire and ice separated only by a line of darkness. Mercury has no atmosphere to retain heat. Earth's air wraps around us like a soft blanket, holding warmth through the night. Mercury has no such comfort. Its gravity is too weak, and the solar wind too strong for any lasting atmosphere to cling to its surface. What little gas occasionally gathers there is quickly swept away, so when the Sun sets on Mercury, the heat simply escapes, rising silently into space, leaving the surface to grow cold with nothing to hold the warmth in place. Mercury is only slightly larger than Earth's moon. When we think of planets, we often imagine vast worlds, but Mercury is remarkably small, a compact rocky sphere that would fit comfortably beside our own familiar moon. Its diameter is just under 5,000 kilometers, while the moon's is about 3,400. They are neighbors in size, both ancient and cratered, both airless. There is something quietly comforting in knowing that the moon we see each night is a close companion in scale to the innermost planet of our solar system. Mercury rotates so slowly, it completes 3 rotations for every 2 orbits around the Sun. This unusual relationship between its spin and its path is called a spin-orbit resonance. For every 2 years Mercury experiences, it turns on its axis exactly 3 times. This means a single day on Mercury, from one sunrise to the next, lasts about 176 Earth days. The sun rises, climbs slowly across the black sky, and sets in a motion so gradual it would be nearly imperceptible. Time on Mercury moves at its own ancient, unhurried pace. Mercury has a surprisingly large iron core relative to its size. Beneath its cratered surface lies a core that takes up about 85% of the planet's radius, far larger proportionally than the cores of other rocky planets. Scientists believe Mercury may have formed with a larger rocky outer layer that was stripped away long ago by a massive collision or by the intense heat of the early sun. What remains is a world that is, in a sense, mostly core, dense and iron-rich, carrying a deep metallic heart beneath its quiet gray face. Mercury's surface is covered in ancient impact craters. Billions of years ago, when the solar system was young and crowded with debris, Mercury was struck again and again by asteroids and comets. Without weather or geological activity to wear them away, those craters remain exactly as they formed, preserved in silence across the ages. Each one is a record of a moment-long past, a quiet scar in the rock. Standing on Mercury's surface, you would be surrounded by the oldest, most undisturbed landscape in the inner solar system, unchanged since the dawn of time. Let your body settle now, just a little more deeply. Feel the weight of your arms, your shoulders, your legs, all of it softening into wherever you are resting. There is nothing you need to hold on to right now, nothing to solve, nothing to remember. Simply let your breath move slowly in and out, like a tide that knows exactly what it is doing. You are safe, you are still, and the night is quiet all around you. Let your thoughts drift gently, like dust motes floating in soft light, unhurried and weightless. There is nowhere else to be. The Caloris Basin on Mercury is one of the largest impact craters in the solar system. It stretches roughly 1,500 kilometers across, wide enough to contain a small continent. Long ago, something enormous struck Mercury here, releasing energy so immense it sent shockwaves rippling across the entire planet. On the opposite side of Mercury, those waves converged and buckled the ground into strange, jumbled terrain. Today, the basin is still and vast, ringed by ancient mountains, a quiet monument to the most violent moment in Mercury's long history. Mercury has ice hidden in permanently shadowed polar craters. Though Mercury sits so close to the Sun, the floors of certain craters near its poles never receive a single ray of sunlight. The Sun always hangs low on the horizon there, and the crater walls cast permanent, deep shadow. In that cold and ancient darkness, water ice has quietly gathered over billions of years, delivered perhaps by comets and asteroids long ago. It rests there still, frozen and undisturbed, hidden just beneath a thin layer of dark, insulating dust. Mercury has no moons. It travels its path around the Sun entirely alone, without a companion world to orbit beside it. The sky above Mercury is simply black and open, filled with stars and the overwhelming presence of the nearby Sun, but no moon hanging softly overhead, no reflected light crossing the surface at night. There is a quiet simplicity to this solitude. Mercury needs nothing more than its own steady path, circling the Sun in silence, unhurried and complete all by itself. Venus is the second planet from the Sun. Drifting further outward from Mercury, we arrive at a world that, from a distance, glows with a soft, creamy brilliance. Venus orbits at about 108 million kilometers from the Sun, roughly 41 million kilometers farther out than Mercury. It is a world of similar size to Earth, and for a long time, people imagined it might be a gentle, tropical place beneath those bright clouds. Venus keeps its secrets well. wrapped in layers of light that reveal nothing of what lies beneath. Venus has the longest rotation period of any planet, taking 243 Earth days to spin once. While Earth completes a full turn in 24 hours, Venus barely moves. It rotates with extraordinary patience, as though it has all the time in the universe. If you could stand on its surface and watch the stars, which of course you cannot, beneath those thick clouds, they would wheel overhead with almost imperceptible slowness. Venus keeps its own deep, unhurried time, indifferent to the rushing pace of the rest of the solar system. Venus rotates backwards compared to most planets, while nearly all the planets spin in the same direction, counterclockwise when viewed from above. Venus turns the other way in what is called retrograde rotation. If you could stand on Venus and watch the sun rise, it would rise in the west and set in the east. Scientists believe this unusual spin may be the result of a massive collision long ago, or perhaps the slow, complex pull of gravitational forces over billions of years. Venus simply chose its own quiet direction and has kept it ever since. A day on Venus is longer than its year. Because Venus rotates so slowly, taking 243 Earth days to spin once, but orbits the Sun in only 225 Earth days, a single Venusian day is actually longer than a full Venusian year. Venus travels all the way around the Sun before it even finishes one rotation. It is a gentle paradox, a world where time folds quietly back on itself. The year ends before the day does, and Venus continues on, unhurried in its own soft and ancient rhythm. Venus has a surface temperature of about 465 degrees Celsius. Beneath those thick, bright clouds, the surface of Venus is extraordinarily, relentlessly hot. Rocks glow faintly in the heat. Lead would melt there as easily as ice melts in sunlight here on Earth. The temperature never drops at night, never changes with the seasons, because the thick atmosphere holds the heat in with a grip that never loosens. It is a world frozen in its own extreme warmth, unchanging, ancient, and quietly, profoundly inhospitable. Venus is the hottest planet in the solar system, despite not being closest to the Sun. Mercury sits far nearer to the Sun, yet Venus is hotter. The reason is its thick blanket of carbon dioxide atmosphere, which traps heat in a powerful greenhouse effect. Sunlight passes through the clouds and warms the surface, but the heat cannot escape back into space. It builds and builds, held in place by that dense, heavy sky. Venus is a gentle reminder that it is not always proximity that determines warmth. Sometimes it is simply what you carry with you. Venus has a thick atmosphere composed mostly of carbon dioxide. That great blanket of gas wrapping Venus is not thin or delicate. It is dense and heavy, pressing down with enormous weight. Carbon dioxide makes up more than 96% of it, trapping heat, bending light, and turning the sky above the surface into a dim amber haze. This is the same gas that trees quietly breathe in here on Earth, but on Venus it has accumulated over billions of years into something vast and all-encompassing. It is a sky that holds everything in, gently and completely, letting nothing escape. Let yourself settle now, just a little more deeply. If there is any tension left in your shoulders, let it soften. If your thoughts are still moving, allow them to slow, like clouds drifting apart on a still evening. You have nowhere to go. There is nothing to solve or remember right now. Just breathe slowly and easily, and let each breath carry you a little further from the day. You are safe, you are still, and the night is holding you gently. Rest is already here. The atmospheric pressure on Venus is about 92 times that of Earth. Standing on the surface of Venus, you would feel the weight of that atmosphere pressing in from every direction, as much pressure as you would feel diving nearly 1 kilometer beneath the ocean here on Earth. The early Soviet spacecraft that landed on Venus were crushed or silenced within hours, simply by the weight of that sky. And yet, from space, Venus looks soft and luminous, a gentle cream-white sphere. All that immense pressure is hidden beneath a surface of quiet, glowing clouds. Venus is perpetually covered by thick sulfuric acid clouds. The clouds that make Venus so bright and beautiful from afar are made not of water, but of tiny droplets of sulfuric acid, layered in bands that circle the entire planet without a break. They never part. No sunlight ever reaches the surface directly. The sky above Venus is always overcast, always the same dim, orange-tinted twilight. And yet those clouds, seen from space, reflect sunlight so brilliantly that they make Venus the brightest planet in our sky. Beauty, as it turns out, can wear many unexpected forms. Venus has thousands of volcanoes on its surface. Beneath those unbroken clouds, the surface of Venus is dotted with more volcanoes than any other planet in the solar system. Scientists estimate there may be over 1 million volcanic features of various sizes. Many appear to be ancient, their lava flows long since cooled and still. But scientists believe some may still be active today, quietly releasing heat from deep within. Venus is a world shaped by its own interior fire. Its surface a record of eruptions and flows stretching back billions of years, written in dark, hardened stone. Maxwell Montes on Venus is taller than Mount Everest. Among the mountains of Venus, Maxwell Montes rises as the tallest, reaching about 11 kilometers above the surrounding plains. Higher than Mount Everest stands above sea level here on Earth. It is a massive, ancient mountain range, and at its high peaks, the temperature drops just enough that certain metallic compounds may settle there like a strange, shimmering frost. It is one of the cooler places on Venus, though still far hotter than anywhere on Earth. A mountain of fire and metal, standing quietly in the amber dark. Venus has no moons. For all its size and brightness, Venus travels alone. No moon circles it. No smaller world keeps it company in its orbit. Earth has its moon. Mars has 2 small companions, but Venus moves through space in quiet solitude. Scientists are not entirely certain why. Perhaps a moon once existed and was lost long ago, nudged away by gravitational forces over billions of years. Or perhaps Venus simply never captured one. Either way, Venus completes its slow, backward journey around the Sun entirely on its own, unhurried and self-contained. Venus is the brightest natural object in the night sky after the Moon. On clear evenings, Venus shines so brilliantly that it can cast faint shadows on the ground. It is often the first point of light to appear after sunset, low on the western horizon, glowing with a steady, unwavering brightness. Ancient peoples called it the evening star and the morning star, not realizing both were the same world seen at different times. Its thick, reflective clouds bounce sunlight back into space with remarkable efficiency, making this hot, strange world one of the most beautiful sights in our quiet night sky. Earth is the third planet from the Sun. After Mercury and Venus, Earth takes its place, the third world in our solar family, orbiting at a distance of about 149.6 million kilometers from the Sun. That distance is so perfectly balanced that liquid water can exist on its surface, that seasons come and go gently, that life can breathe and grow. Astronomers even use Earth's distance from the Sun as a unit of measurement, one astronomical unit, a quiet acknowledgement that this is the world we know best, the one we measure all others against. Earth is the only known planet to harbor life. Of all the worlds we have studied, the 8 planets, the moons, the dwarf planets, the countless bodies drifting through our solar system, only one is known to be alive. Earth teems with life in every corner, in the deepest ocean trenches, in frozen polar ice, in the driest deserts, in the thin upper reaches of the atmosphere. Scientists believe other worlds may hold life too, and the search continues with quiet hope. But for now, Earth remains the one place in all the vast silent solar system where something breathes, grows, and wonders. Earth has a powerful magnetic field generated by its liquid iron outer core. Deep beneath our feet, far below the crust and the solid mantle, Earth's outer core is a vast ocean of molten iron and nickel slowly churning. As it moves, it generates electric currents, and those currents produce a magnetic field that wraps around the entire planet. This invisible shield deflects harmful charged particles streaming from the sun, protecting the surface, protecting the air, protecting every living thing that breathes and grows here. Earth's atmosphere is 78% nitrogen and 21% oxygen. The air we breathe is mostly nitrogen, a quiet, stable gas that dilutes the oxygen and keeps the atmosphere from being too reactive. The remaining 21% is the oxygen that fills our lungs with each slow, easy breath. Trace amounts of argon, carbon dioxide, and water vapor make up the rest. This precise, delicate mixture has remained remarkably stable for hundreds of millions of years. A gentle balance that allows life to continue, breath after breath, moment after quiet moment. Let yourself settle a little more deeply into wherever you are resting now. Feel the weight of your body becoming heavier, softer, more still. There is nothing you need to hold on to, nothing you need to remember or figure out tonight. Let your breathing slow, just a little. Let each breath out carry away whatever remains of the day. You are here, you are safe, and the world is turning slowly and quietly beneath you, as it always has, as it always will. Simply rest. Earth is the densest planet in the solar system. Despite being neither the largest nor the most massive of the planets, Earth packs more mass into each unit of its volume than any other world we know. Its dense iron and nickel core, combined with its heavy rocky mantle and crust, give it an average density of about 5.5 grams per cubic centimeter. This remarkable density is part of what makes Earth so geologically active, so magnetically alive, so different from the lighter gas giants drifting farther out in the solar family. Earth's surface is about 71% covered by liquid water. More than two-thirds of this world is ocean, vast, deep, and quietly alive. From space, Earth appears overwhelmingly blue, a shimmering sphere, unlike anything else in the solar system. The oceans hold most of Earth's water, reaching average depths of nearly 3.7 kilometers in places. They regulate temperature, carry heat around the globe, and shelter more life than we have yet fully counted. All that blue, all that stillness on the surface, and all that quiet depth below. Earth has one large natural satellite, the Moon. Our moon is not a small, faint companion. It is a substantial world, about 1/4 the diameter of Earth itself. It orbits at an average distance of about 384,000 kilometers, close enough that its gravitational pull raises tides in our oceans twice each day. The moon is the only place beyond Earth where human beings have stood and looked back at their home. It glows in our night sky with borrowed sunlight, steady and familiar, a quiet companion to every night that has ever passed. The moon stabilizes Earth's axial tilt, moderating its climate. Without the moon's gravitational influence, Earth's axial tilt would wobble chaotically over thousands of years, shifting dramatically, perhaps tilting so far that the poles face the sun directly, reshaping climates beyond recognition. The moon acts as a gentle anchor, keeping that tilt steady within a narrow, predictable range. This stability has allowed Earth's seasons to remain consistent for hundreds of millions of years, creating the reliable rhythms of warmth and cold, growth and rest that life has come to depend upon. Earth completes one orbit around the Sun in 365.25 days, 1 year, the time it takes our world to travel its full elliptical path around the Sun, covering nearly 940 million kilometers. That extra quarter of a day accumulates quietly over time, which is why every 4 years we add a leap day to our calendar, keeping our human timekeeping gently aligned with the rhythm of the cosmos. The orbit is nearly circular, smooth and unhurried, carrying us through the warmth of summer and the quiet of winter in one long, continuous arc. Earth's axial tilt of 23.5 degrees causes the seasons. Because Earth does not stand perfectly upright as it orbits the Sun, different parts of the planet receive more or less sunlight at different times of year. When the northern hemisphere tilts toward the Sun, it warms into summer. 6 months later, it tilts away, and the days grow shorter and cooler. This gentle, predictable lean is responsible for every autumn leaf, every spring blossom, every long summer evening, and every quiet winter morning. All of it from one small, steady tilt of 23.5 degrees. Earth has plate tectonics that continuously reshape its surface. Beneath the crust, enormous slabs of rock called tectonic plates drift slowly across the mantle, moving only a few centimeters each year, about as fast as a fingernail grows. Over millions of years, these movements have opened oceans, raised mountain ranges, and rearranged the continents entirely. The world we know today, with its familiar shapes of land and sea, is just one quiet moment in an ongoing, unhurried rearrangement that has been unfolding since Earth was young and will continue long after we are gone. Mars is the fourth planet from the Sun. Sitting just beyond Earth in the quiet order of the solar system, Mars is our nearest outer neighbor, a small, rust-colored world that has captured human imagination for centuries. It orbits the Sun at an average distance of about 228 million kilometers, far enough that sunlight reaches it softer and cooler than it reaches us. From Earth, Mars appears as a faint reddish point of light in the night sky, steady and unhurried. Mars has a thin atmosphere composed mostly of carbon dioxide. Unlike Earth's rich, breathable air, the Martian atmosphere is extraordinarily thin, less than 1% as dense as our own. It is made up almost entirely of carbon dioxide, with tiny traces of nitrogen and argon. This delicate veil of gas offers little warmth and almost no protection. Temperatures on Mars can drop to -125 degrees Celsius on a winter night, and even a warm afternoon rarely climbs above freezing. Mars has the tallest volcano in the solar system, known as Olympus Mons. This immense shield volcano sits on the western edge of a vast volcanic plateau called the Tharsis region, rising so high it pierces above most of the Martian atmosphere. Its base is so wide that if you stood at its center, the edges would lie beyond the horizon, invisible to you. Olympus Mons is not jagged or sharp. It is broad and gently sloping, like a slow, enormous breath rising from the surface of the planet. Let your body grow a little heavier now. Feel the weight of your shoulders, your arms, your hands, all resting, all releasing. There is nothing to hold on to. Let your breath slow just a little more, each exhale carrying the last traces of the day gently away. You are safe and still. Let your thoughts drift like dust on a quiet breeze, rising and dissolving without effort. There is nowhere to be and nothing to do, simply rest. Olympus Mons rises about 22 kilometers above the Martian surface and is roughly the size of France. To stand at its summit would be to stand higher than any mountain on Earth, nearly 3 times the height of Mount Everest. And yet it spreads so gradually across the landscape that its slopes are barely steeper than a gentle hill. The entire country of France could nestle within its base, with room to spare. It is a monument of quiet geological patience, built up slowly over billions of years. Valles Marineris on Mars is the longest canyon system in the solar system, stretching nearly 4,000 kilometers across the Martian surface, roughly the width of the continental United States. This immense system of valleys and chasms would dwarf the Grand Canyon many times over. In places it reaches 10 kilometers deep, and 600 kilometers wide. It was not carved by a river, but formed by ancient rifting of the crust, the land slowly pulling apart over millions of years, leaving this vast silent wound across the face of Mars. Mars has two small moons, named Phobos and Deimos. Unlike our own large, luminous moon, these two companions are tiny and irregular, more like captured asteroids than true moons. Phobos, the larger of the two, is only about 22 kilometers across, while Deimos is even smaller at about 12 kilometers. From the surface of Mars, they would appear not as glowing disks, but as faint, star-like points of light moving quietly across the night sky. Their names mean fear and dread in ancient Greek, though they drift above Mars in perfect, quiet peace. Phobos orbits Mars faster than Mars rotates. This makes Phobos one of the most unusual moons in the solar system. It rises in the west and sets in the east, moving in the opposite direction of the Sun across the Martian sky. It completes a full orbit in just 7 hours and 39 minutes, meaning it circles Mars nearly 3 times in a single Martian day. From the ground, it would appear to race across the sky with quiet urgency, a small, silent traveler moving steadily against the turning of the world beneath it. Mars has a reddish color due to iron oxide on its surface. Iron oxide, the same compound we know as rust, coats the Martian soil and dust in a fine, warm layer of red. Billions of years ago, Mars may have had liquid water and a thicker atmosphere, and iron in the rocks reacted slowly with oxygen to form this rust. Over time, the wind spread the dust everywhere, giving the entire planet its distinctive color. That soft, warm redness is essentially the whole world, slowly, gently rusting, a quiet transformation unfolding across geological time. Mars experiences planet-wide dust storms that can last for months. When conditions are right, dust lifted from the surface by warm air spreads outward until it eventually blankets the entire planet in a soft, hazy veil. The sky turns from its usual pale pink to a deep, murky amber, and sunlight dims to a faint glow. These storms can persist for weeks or even months before the dust slowly settles back to the ground. There is something almost meditative about them, the whole planet wrapped in a quiet, drifting haze, waiting for stillness to return. Mars has polar ice caps made of water ice and dry ice. At both the north and south poles of Mars, layers of ice accumulate through the long Martian seasons, water ice that persists year-round, and a seasonal coating of frozen carbon dioxide that forms and retreats with the changing temperatures. The southern cap, in particular, holds a thick, permanent layer of dry ice, even in summer. These pale, quiet caps shimmer faintly at the top and bottom of the planet, like soft crowns of frost resting on a sleeping world. A Martian day lasts about 24 hours and 37 minutes. This makes the Martian day remarkably close to our own, so close that early Mars rover teams could almost follow Earth schedules on the red planet. The extra 37 minutes adds up slowly, drifting the Martian clock gently out of step with hours over weeks and months. There is something quietly comforting in this similarity that far across the solar system, another world turns beneath its sun at nearly the same gentle, unhurried pace as our own. Mars has the largest dust devils in the solar system. On warm Martian afternoons, columns of spinning, dust-filled air rise from the heated surface and spiral slowly upward into the thin atmosphere. Some of these towering whirlwinds reach heights of 8 kilometers or more, far taller than any dust devil found on Earth. They drift across the plains in long, wandering paths, their pale columns catching the low sunlight. From a distance, they look almost graceful, slow-moving pillars of dust turning quietly across an empty, ancient landscape. Evidence suggests liquid water once flowed on the surface of Mars. Ancient riverbeds, flood channels, and smooth, rounded pebbles found by rovers all tell a quiet story of a wetter, warmer past. Billions of years ago, water may have carved valleys and filled low-lying basins across the Martian surface. That water is long gone now, locked in ice, absorbed into rock, or lost to space, but the landscape still holds the memory of it in gentle curves and worn stones. Mars carries its past like a faint, faded watermark pressed into the land. Let yourself rest here for a moment. There is nothing you need to remember, nothing you need to hold on to. Allow your body to grow heavier and softer with each slow breath. Let your thoughts drift like dust on a quiet wind, rising gently, then settling back to stillness. You are safe, you are still, and there is nowhere else you need to be. Simply breathe and let the warmth of rest move through you, slowly and completely. Mars has roughly half the diameter of Earth. If you could place Earth and Mars side by side, Mars would look like a smaller, quieter companion, its surface area about equal to all the dry land on Earth. Despite its modest size, Mars holds the tallest volcano and the longest canyon in the solar system, as though it packed an outsized grandeur into a smaller frame. There is something gently humbling in that, a world half our size, wearing its ancient landscapes with a quiet and unhurried dignity. The asteroid belt lies between Mars and Jupiter. In the wide, quiet space between the fourth and fifth planets, countless rocky bodies orbit the Sun in a broad, loosely scattered ring. This region is not a dense wall of rock, as it is sometimes imagined. It is mostly open space, with individual asteroids separated by vast distances of empty silence. The belt marks a natural boundary in the solar system, the place where the rocky inner worlds give way to the enormous gas giants waiting further out in the dark. The asteroid belt contains millions of rocky bodies, but relatively little total mass. Though the number of objects is vast, if you gathered every asteroid in the belt together, their combined mass would be less than 4% of the Moon's mass. Most of these bodies are small, pebbles and boulders, and irregular chunks of rock and metal, tumbling slowly through the dark. The belt is more like a quiet scattering of ancient debris than a solid structure, each fragment a remnant from the early solar system, drifting patiently through the ages. Ceres is the largest object in the asteroid belt and a dwarf planet. Roughly 945 kilometers across, Ceres is large enough that its own gravity has pulled it into a nearly spherical shape, something most asteroids never achieve. Scientists believe it may hold a significant amount of water ice beneath its surface, and some regions show bright, reflective spots that hint at ancient salt deposits. Ceres sits quietly at the center of the belt, a small, round world among a sea of irregular fragments, dignified in its stillness. Jupiter is the fifth planet from the Sun. Beyond the quiet scatter of the asteroid belt, Jupiter emerges, vast, luminous, and unmistakable. It is the first of the great outer worlds, a giant that has shaped the solar system around it through the quiet authority of its enormous gravity. Even from Earth, Jupiter is visible to the naked eye as a steady, bright point of light moving slowly among the stars. It has been there, turning in the dark, for 4.6 billion years, patient, immense, and serene. Jupiter is the largest planet in the solar system. It is so vast that more than 1,300 Earths could fit inside it, and yet it wears that size with a kind of effortless calm. Its swirling bands of cloud, cream and amber and soft brown wrap around it in slow, continuous rivers of gas. From a great distance, Jupiter looks almost like a painting, its surface alive with gentle motion, turning slowly in the dark as it has always done. Jupiter's mass is more than twice that of all other planets combined. If you gathered Saturn, Uranus, Neptune, and every other world in the solar system and placed them on one side of a great cosmic scale, Jupiter alone would outweigh them all, and then some. Its gravity reaches far into the solar system, quietly guiding the paths of smaller bodies. There is something deeply peaceful in that thought, one great steady presence, holding so much of the solar system in its gentle gravitational embrace. Jupiter is a gas giant composed mainly of hydrogen and helium. Unlike the rocky worlds closer to the Sun, Jupiter has no solid surface to stand upon. Its atmosphere simply deepens and thickens as you descend, hydrogen slowly becoming denser and stranger under immense pressure. Deep within, scientists believe hydrogen transforms into a liquid metallic state, conducting electricity like a warm, flowing metal sea. It is a world made almost entirely of the same two elements that make up the stars: ancient, elemental, and quietly magnificent. Jupiter has at least 95 known moons. They range from tiny captured rocks, just a few kilometers across, to enormous worlds larger than some planets. Together they form a small solar system of their own, each moon tracing its own quiet path around the giant. Some orbit close and fast. Others drift in wide, slow loops far from Jupiter's cloud tops. There is something wonderfully full about that image. A great planet surrounded by dozens of smaller companions, each one held gently in place by gravity's invisible hand. Ganymede is Jupiter's largest moon and the largest moon in the solar system. It is a world of ancient ice and dark rock, its surface marked by long, pale ridges and broad, shadowed plains that have remained largely unchanged for billions of years. Ganymede is so large that if it orbited the Sun rather than Jupiter, it would be classified as a planet in its own right. It drifts in its quiet orbit, enormous and unhurried, a world unto itself wrapped in the soft gravity of Jupiter's embrace. There is no need to hold on to anything right now. Let your thoughts drift, the way a moon drifts slowly in its orbit. No effort, no resistance, just a quiet, steady movement through the dark. Feel the weight of your body settle. Let your breath come and go softly, without any direction from you. You are resting in the middle of a vast and gentle universe, and you are safe. Let each breath carry you a little further from the day, a little closer to sleep. Ganymede is larger than the planet Mercury. Side by side, Ganymede would be the bigger world, broader across, its surface stretching further in every direction. Mercury, small and dense and close to the Sun, is outmatched in size by this quiet moon of Jupiter. It is one of those gentle reminders that the solar system holds surprises, not in drama, but in the simple, unhurried way things are. A moon larger than a planet, both of them drifting patiently through the dark for billions of years. Io is the most volcanically active body in the solar system. Its surface is painted in vivid yellows and oranges and reds, the colors of sulfur deposited by hundreds of constantly erupting volcanoes. Plumes of gas and ash rise silently into its thin atmosphere, and rivers of molten rock creep slowly across a landscape that is always changing. Io is shaped by the tidal forces of Jupiter pulling and squeezing it with every orbit, like a hand gently kneading soft clay, generating the heat that keeps its interior molten and alive. Europa has a global subsurface ocean beneath its icy crust. Beneath a shell of cracked and frozen ice, scientists believe a vast liquid ocean stretches around the entire moon, kept warm not by the sun, but by the same tidal forces that stir Io's volcanoes. The surface is smooth and pale, crossed by long reddish lines where the ice has shifted and refrozen over ages. That hidden ocean, dark and deep and quiet, is one of the most compelling places in the solar system, a world of water wrapped in ice, drifting silently around Jupiter. Callisto is one of the most heavily cratered objects in the solar system. Its ancient, dark surface is covered so completely in overlapping craters that it holds a record of nearly every impact it has ever received, stretching back billions of years. Unlike Io or Europa, Callisto is geologically quiet. No volcanoes reshape it, no tidal forces resurface it. It simply holds its history in silence, each crater a soft impression left by something that passed long ago. It is the oldest-looking face in Jupiter's family of moons, still, dark, and deeply patient. Jupiter's Great Red Spot is a storm that has persisted for centuries. Wider than the entire Earth, this vast swirling oval has been turning slowly in Jupiter's southern atmosphere for at least 300 years, perhaps longer. It is not a violent thing from a distance. It looks almost like a gentle eye, soft and amber road, rotating with a patience that makes our own storms seem like brief sighs. Generation after generation of human observers have looked up and found it there, unchanged, enduring, quietly turning. The Great Red Spot is shrinking over time. When astronomers first measured it carefully, it spanned more than 40,000 kilometers across. Today it is considerably smaller, still enormous, still ancient, but gradually contracting with each passing decade. Scientists are not entirely certain why. The change is slow and quiet, almost imperceptible from year to year, like a breath being gently released. Whatever its eventual fate, the Great Red Spot has already endured longer than any storm in recorded human history, and it continues to turn. Jupiter has a faint ring system, discovered by Voyager 1. Unlike Saturn's brilliant rings, Jupiter's are thin and dark, made mostly of tiny dust particles shed by 4 of its inner moons. They are nearly invisible from Earth, revealed only when the Voyager 1 spacecraft passed close enough to look back and catch them silhouetted against the faint light of the sun. They are not showy or dramatic. They are quiet, delicate, almost shy. A soft halo around a giant world, easy to miss, beautiful when found. Jupiter's magnetic field is the strongest of any planet in the solar system. It stretches outward for millions of kilometers in every direction, creating a vast invisible bubble called the magnetosphere, so large that if it were visible from Earth, it would appear wider than the full moon in the sky. This immense field is generated deep within Jupiter, where hydrogen under crushing pressure behaves like a liquid metal, conducting electricity in slow, powerful currents. It wraps the planet in a kind of silent, invisible protection, enormous and calm. Jupiter emits more heat than it receives from the Sun. Deep within the planet, the slow gravitational compression of its enormous mass generates warmth, a quiet internal glow that has been radiating outward since Jupiter first formed. This excess heat drifts upward through layer after layer of cloud and gas, rising gently toward space. Jupiter does not need sunlight to stay warm. It carries its own warmth from within, like an ember that has been glowing patiently since the earliest days of the solar system. A day on Jupiter lasts only about 10 hours, the shortest of any planet in the solar system. Despite being so vast, Jupiter spins with remarkable speed, its enormous bulk rotating once in just 10 hours. That rapid spin stretches its clouds into long horizontal bands and flattens the planet slightly at the poles, giving it a gently rounded, slightly squashed shape. Somewhere on Jupiter's cloud tops, a single day passes in the time it takes to have a long, restful sleep. The giant turns quickly, quietly, endlessly. Let yourself settle a little deeper now. There is nowhere to be, nothing to hold on to. Let your thoughts loosen and drift, the way clouds drift slowly across a wide sky. Feel the weight of your body resting, fully supported, completely at ease. Each breath comes and goes without effort, soft and slow. You are here, you are safe, and the whole quiet universe is simply turning around you. Let everything soften, let everything go. Jupiter acts as a gravitational shield, deflecting comets away from the inner solar system. Its immense gravity reaches far out into space, pulling passing comets and asteroids toward itself, or flinging them away before they can travel inward toward Earth. Over billions of years, Jupiter has quietly intercepted countless wandering objects that might otherwise have struck the inner planets. Scientists believe the shielding role may have helped create the stable conditions that allowed life to develop on Earth, a vast silent guardian, drifting in the dark. Saturn is the 6th planet from the Sun. Beyond Jupiter, at a distance of roughly 1,400,000,000 kilometers from the Sun on average, Saturn drifts in a wide, unhurried orbit. It takes nearly 30 Earth years to complete a single journey around the Sun, a slow, patient circuit through the outer solar system. From where we stand on Earth, Saturn appears as a steady golden point of light in the night sky, calm and unhurried, one of the most beautiful sights the sky has to offer. Saturn is the second largest planet in the solar system. Only Jupiter surpasses it in size. Saturn is so wide that roughly 9 Earths could fit side by side across its equator. And yet for all its vastness, it carries itself with a kind of quiet elegance. Its soft golden color, its sweeping rings, its gentle glow in the outer dark. There is something deeply peaceful about Saturn, something that invites stillness. It is a world of great scale and great beauty, turning slowly in the silence of space. Saturn has the most spectacular and extensive ring system of any planet. Of all the worlds in our solar system, none wears its beauty quite so openly as Saturn. Its rings sweep outward in broad, luminous arcs, catching the distant sunlight and glowing like bands of soft silver and gold. No other planet displays anything quite so breathtaking, so wide, so intricate, so quietly magnificent. Saturn's rings are simply one of the most beautiful things in the known universe. Saturn's rings are made mostly of ice particles and rocky debris. If you could hold a piece of Saturn's rings in your hands, you might find a chunk of ice no larger than a snowball or a fragment of rock dusted in frost. The rings are composed of countless such pieces, ranging from tiny grains to boulders several meters across, all slowly orbiting Saturn together, tumbling gently through space in a vast, slow river of ice and stone. Saturn's rings span about 282,000 kilometers from edge to edge. Laid flat, they would stretch nearly 3/4 of the distance from Earth to the Moon. That is an almost incomprehensible width, a shimmering disk of ice and debris so vast it would take light nearly a full second to cross from one edge to the other. And yet they circle Saturn in graceful silence, unhurried and impossibly wide, drifting through the outer dark. Saturn's rings are remarkably thin, often less than a kilometer thick. Despite spanning hundreds of thousands of kilometers across, the rings are extraordinarily flat, in some places barely a few hundred meters deep. If Saturn's rings were scaled down to the width of a piece of paper, they would stretch across a football field. This delicate thinness makes them all the more remarkable, vast in one direction, almost impossibly slender in another, like a whisper stretched across the sky. Saturn has at least 146 known moons, the most of any planet. They range enormously in size and character, from Titan, a world larger than the planet Mercury, down to tiny irregular bodies just a few kilometers across. Some orbit in neat, orderly paths close to Saturn, while others wander in distant, tilted loops far out in the dark. Together they form a quiet family of worlds, each one drifting in its own patient orbit around the ringed giant. Titan is Saturn's largest moon and has a thick nitrogen atmosphere. Titan is the only moon in the solar system known to have a substantial atmosphere, a hazy, orange-tinted envelope of nitrogen and methane that shrouds its surface in a perpetual amber glow. In some ways, Titan feels almost familiar, with weather systems, seasons, and a fixed sky overhead. And yet it is profoundly alien, cold beyond imagining, its air unbreathable, its skies forever veiled in soft burnt orange haze. Titan has lakes and seas of liquid methane on its surface. Not water, but methane, flowing in dark, still pools across Titan's cold plains, gathering into broad, shallow seas near its northern pole. The largest of these, called Krakenmeer, is thought to be larger than Earth's Caspian Sea. In the dim amber light, these methane seas lie perfectly calm, reflecting the hazy sky above them. It is a world of quiet liquid stillness, unlike anything else we know. Let yourself rest a little more deeply now. There is nothing you need to hold on to, nothing you need to figure out. Let your thoughts grow quieter, the way a lake grows still when the wind fades away. Feel your body heavy and warm, fully at ease. Each breath is slow and gentle. The universe is vast and peaceful around you, and you are safe within it. Let your mind soften. Let sleep come slowly, like a tide moving in, quiet, patient, and kind. Enceladus has geysers of water vapor erupting from its south pole. Beneath the icy crust of this small moon, scientists believe, lies a global ocean of liquid water, and at the South Pole, that ocean vents itself into space through long cracks in the ice called tiger stripes. Tall plumes of water vapor and ice crystals rise silently into the darkness above, drifting outward into Saturn's rings. It is one of the most quietly astonishing sights in the solar system, a small moon breathing into space. Saturn is the least dense planet and could theoretically float on water. Of all the planets, Saturn is the lightest for its size, so low in density that if you could place it in an ocean vast enough to hold it, it would float. Saturn is composed mostly of hydrogen and helium, with no solid surface, its enormous volume filled with swirling gas and slowly deepening layers of fluid. For all its grandeur and scale, it is, in a sense, a world made almost of nothing, vast, golden, and impossibly light. Saturn's hexagonal polar storm is a unique atmospheric feature. At Saturn's north pole, a vast six-sided storm system stretches nearly 13,000 kilometers across, wider than the entire Earth. Scientists believe it has persisted for decades, possibly much longer. Each side of the hexagon is almost perfectly straight, drawn by the planet's own winds and rotation. It sits there quietly, turning, a geometric wonder written in cloud and wind, at the top of a golden world. A year on Saturn lasts about 29.5 Earth years. Saturn moves with great patience around the Sun, tracing its slow, wide arc through the outer solar system. A child born on Earth might grow nearly to adulthood before Saturn completes a single orbit. Each of its seasons stretches across many Earth years, long, slow winters and summers, unfolding in silence. Time on Saturn moves at its own unhurried pace, vast and calm. Uranus is the seventh planet from the Sun. Beyond Saturn, the solar system grows quieter and more remote. Uranus drifts in that deep outer stillness, a pale blue-green world wrapped in cold and cloud. It sits nearly 3 billion kilometers from the Sun, on average, a distance so vast that sunlight, traveling at its extraordinary speed, still takes more than 2.5 hours to reach it. It is a world of serene, unhurried distance. Uranus is classified as an ice giant. Unlike Jupiter and Saturn, which are composed mostly of hydrogen and helium gas, Uranus is made largely of water, methane, and ammonia in dense icy forms deep within its interior. Scientists call it an ice giant not because it is frozen solid, but because these materials exist in a thick, slushy layer beneath its outer atmosphere. It is a different kind of world, quieter, denser, and wrapped in a cold, soft mystery. Uranus rotates on its side with an axial tilt of about 98 degrees. While most planets spin upright like a top, Uranus rolls along its orbital path nearly on its side, its poles pointing roughly toward and away from the Sun. Scientists believe a collision with a large body long ago knocked it into this unusual orientation. It moves through the solar system in its own quiet, unhurried way, tilted, gentle, and unlike anything else we know. Uranus's extreme tilt means each pole experiences about 42 years of continuous sunlight, then darkness. As Uranus slowly orbits the Sun, one pole gradually turns to face the light for decades at a time, while the other rests in unbroken darkness. Then, slowly, they trade places. Seasons on Uranus are among the longest and strangest in the solar system. Long, slow dawns and dusks measured not in hours but in years. It is a world of enormous, patient cycles. Uranus has 13 known rings. Unlike Saturn's broad, bright bands, the rings of Uranus are narrow, dark and subtle, thin lines of dust and small rocky particles encircling the tilted planet. They were discovered in 1977 when Uranus passed in front of a distant star and its rings briefly dimmed the starlight. They are quiet things, easy to miss, orbiting in the cold and dark around a pale world at the edge of the familiar solar system. Uranus has 28 known moons, all named after Shakespeare and Alexander Pope characters. Ariel, Oberon, Titania, Miranda, Puck, their names carry the gentle weight of old poetry and theater, borrowed from plays and verses written centuries ago on Earth. It is a quiet kind of wonder that worlds of ice and rock in the cold outer solar system should carry the names of fairies and spirits and dreamers. They drift in slow orbits around their tilted planet, named for things imagined, long before they were found. Let yourself settle a little more deeply now. There is nowhere to go, nothing to do, nothing to hold in your mind. Let your thoughts drift like moons in slow, quiet orbits, unhurried, weightless, moving gently through the dark. Feel your breath rising and falling, soft and even. Your body is heavy and warm and at rest. The universe turns slowly around you, patient and vast. You are held and safe and still. Let sleep come softly, like light fading at the edge of a long, quiet day. Miranda, a moon of Uranus, has the tallest known cliff in the solar system, called Verona Rupes. This cliff face drops roughly 20 kilometers straight down, more than 10 times the height of Earth's deepest ocean trench. Scientists believe it formed from ancient geological upheaval on this small patchwork world. Miranda's surface is a quiet mosaic of canyons, ridges, and plains, as if pieces of different worlds were gently pressed together. It is a small moon carrying an enormous, silent drop. Uranus holds the record for the coldest planetary atmosphere in the solar system. Even though it is not the farthest planet from the Sun, its temperatures can drop to around -224 degrees Celsius, colder than Neptune, despite being closer to the warmth of our star. Scientists believe this may be because Uranus releases very little of its internal heat outward. It is a still and frozen world, quietly holding its cold close, like a deep winter that never quite ends. Uranus appears blue-green because methane gas in its atmosphere absorbs red light and reflects the cooler wavelengths back into space. The result is that soft, gentle color somewhere between the blue of a winter sky and the green of still, shallow water. It is one of the quieter beauties of the solar system, a color born not from pigment or reflection, but from the invisible chemistry of a cold and distant atmosphere. That pale hue drifts across billions of kilometers of space, soft and unhurried. Uranus was the first planet discovered with a telescope, found by the astronomer William Herschel in 1781. Before that night, the known solar system ended at Saturn. Herschel was quietly surveying the sky from his garden in Bath, England, when he noticed something that moved against the fixed stars. He at first thought it might be a comet. Slowly, carefully, it revealed itself to be a new world, the first planet added to human knowledge in recorded history, found by patient, unhurried watching. A year on Uranus lasts about 84 Earth years. One slow, patient orbit carrying this tilted ice giant all the way around the Sun and back again. A person born on Earth would live nearly their entire life in the span of a single Uranian year. The seasons there stretch across decades, each pole spending roughly 42 years in sunlight and 42 years in darkness. Time moves differently at the edge of the familiar solar system, quietly, unhurried, measured in lifetimes. Neptune is the eighth and farthest planet from the Sun. It sits at an average distance of about 4.5 billion kilometers from our star. So far that sunlight, traveling at nearly 300,000 kilometers per second, takes more than 4 hours to reach it. It is a deep blue world, cold and immense, orbiting in a part of the solar system where the Sun appears as little more than a very bright star. Neptune marks the quiet outer boundary of the planetary family. Neptune was discovered mathematically before it was ever seen through a telescope. In the 1840s, astronomers noticed that Uranus was not moving quite as expected. Something unseen was pulling gently on it. Working from mathematics alone, Urbain Le Verrier in France and John Couch Adams in England independently predicted where a new planet must be. When astronomers pointed a telescope to the calculated position in 1846, Neptune was there, almost exactly where the equation said it would be. Neptune has the strongest sustained winds of any planet in the solar system, reaching speeds of about 2,100 kilometers per hour. These are not brief gusts, but enduring, planet-wide streams of atmosphere moving faster than the speed of sound on Earth. It is a strange and quiet contradiction. A world so far from the Sun, so cold and dark, churning with such relentless energy deep in its atmosphere. The winds blow on year after year, unseen and unhurried in the cold outer dark. Neptune has a large storm system called the Great Dark Spot. Though unlike Jupiter's Great Red Spot, it comes and goes over time. When Voyager 2 passed Neptune in 1989, it photographed a vast, dark oval swirling in the southern atmosphere. Years later, when the Hubble Space Telescope looked again, that storm had vanished and new ones had appeared elsewhere. Neptune's storms rise and fade like slow, quiet thoughts, drifting through the deep blue atmosphere and dissolving back into the cold. Neptune is also an ice giant with a composition similar to that of Uranus. Beneath its deep blue atmosphere lie layers of water, ammonia, and methane in a dense, slushy form that scientists sometimes call an ice mantle, not frozen solid, but compressed and hot under enormous pressure. At its center rests a rocky core, small and ancient. Neptune and Uranus are a quiet pair, twin worlds of ice and gas, at the far edge of the solar system, similar in their depths, different in their faces. Let yourself rest now, completely and without effort. There is nothing left to hold, nothing left to follow. Let the planets drift away, one by one, into the quiet dark. Feel the weight of your body settling, soft and still. Your breath is slow and even, rising and falling like a tide on a distant, peaceful shore. The solar system turns without you, patient and vast, and you are here, warm and safe and still. Let your thoughts grow soft. Let sleep come gently now. Neptune has 16 known moons, each one a small, quiet companion in the cold outer dark. They range from large and ancient to tiny and irregular, captured long ago by Neptune's patient gravity. Some orbit close, some drift far out in wide, lonely paths. Together they form a gentle family of frozen worlds, circling their deep blue planet in the silence of the outer solar system, unhurried and serene. Triton is Neptune's largest moon, and it orbits in the opposite direction to Neptune's rotation. This retrograde path is a quiet clue that Triton was not born alongside Neptune, but was captured long ago, drawn in from the cold depths of the outer solar system. It drifts backward against the flow, steady and unhurried, a wanderer that found a new home. Scientists believe it was once a free-roaming body, now gently bound forever. Triton is slowly spiraling inward toward Neptune, and one day, far in the future, Neptune's gravity will pull it apart entirely. This gradual inward drift happens because tidal forces from Neptune gently steal energy from Triton's orbit, drawing it closer over millions of years. It is a slow and peaceful unraveling, unfolding across vast stretches of time. Scientists believe that when it finally breaks apart, it may form a beautiful new ring around Neptune. Triton has geysers of nitrogen gas erupting from its frozen surface, rising several kilometers into its thin atmosphere. These quiet eruptions are driven not by volcanic heat, but by sunlight. Even the faint, distant light of the sun warms nitrogen beneath the surface ice, just enough to send it drifting upward in dark, wispy plumes. Voyager 2 photographed these gentle columns in 1989. They are soft, unhurried fountains on one of the coldest worlds we know. Neptune has a faint ring system, delicate and incomplete, with distinct curved sections known as arcs. Unlike Saturn's broad, bright rings, Neptune's are dim and narrow, barely visible even to powerful telescopes. The arcs are named with gentle words: courage, liberty, equality, and freedom. Quiet names for quiet structures drifting in the dark. They are held in place by the gravitational influence of nearby small moons, patient and still in the cold outer reaches. A year on Neptune lasts about 165 Earth years. Neptune moves so slowly along its vast orbit that a single journey around the Sun takes longer than a human lifetime. Seasons on Neptune stretch across decades, and its slow passage through the sky is barely perceptible from year to year. It is a world that lives on a different time scale entirely, unhurried, immense, patient beyond all ordinary measure. Neptune completed its very first full orbit since its discovery only in the year 2011. Astronomers first observed Neptune in 1846, and for 165 years it traveled its immense path, unseen in its entirety. When it finally returned to the same point in the sky where it had been first spotted, it was a quiet and remarkable milestone. One slow, patient circle, completed across the span of generations. Neptune receives about 900 times less sunlight than Earth, due to its vast distance from the Sun. At that remote distance, the Sun is little more than a very bright star, brilliant compared to the surrounding darkness, but delivering only a whisper of warmth. And yet Neptune's atmosphere churns, its winds blow, and its clouds drift. It is a world that endures on almost nothing, quiet and self-contained in the cold, dim reaches of the outer solar system. Pluto was reclassified as a dwarf planet in 2006, when the International Astronomical Union formally defined what it means to be a planet. Pluto had been considered the 9th planet since its discovery in 1930, but it was ultimately found to share its orbital neighborhood with many other similar bodies in the Kuiper belt. The reclassification was not a demotion so much as a gentle clarification, a recognition that Pluto belongs to a rich and fascinating family of distant worlds. Pluto has a vast heart-shaped plain of nitrogen ice on its surface, named Tombaugh Regio, in honor of Clyde Tombaugh, who discovered Pluto in 1930. This enormous, bright feature stretches across hundreds of kilometers and was first revealed in stunning detail by the New Horizons spacecraft in 2015. It is one of the most unexpectedly beautiful sights in the solar system. A quiet heart, frozen and pale, resting on a small world at the edge of everything we know. Let yourself settle now, just a little more deeply. Feel the weight of your body resting, fully supported, with nothing left to carry. Let your breath slow on its own. There is no pace to keep, no thought to follow. The planets continue their long, patient journeys through the dark, and you are here, still and warm, drifting quietly toward rest. There is nothing to do now but let go. Pluto has 5 known moons, and its largest, Charon, is so big relative to Pluto that the two are considered a binary system. Rather than one body clearly orbiting the other, they orbit a shared point in space between them, slowly circling each other like two quiet companions. Charon is roughly half the size of Pluto, an extraordinary pairing, drifting together in the cold and distant dark, bound to each other across all of time. Charon and Pluto are tidally locked, each always showing the same face to the other. If you stood on the side of Pluto facing Charon, that large gray moon would hang permanently in the sky, never rising or setting, simply resting there above the frozen landscape. And from Charon, Pluto would do the same, fixed and still, a pale companion always present. Two worlds, quietly watching each other across the void. When Pluto travels far from the Sun, its thin atmosphere collapses and freezes directly onto its surface. As it moves along its long elliptical orbit and the faint warmth of the Sun fades even further, the nitrogen and methane gases that form its atmosphere simply settle down as frost. Then, centuries later, as Pluto slowly draws closer again, those frozen layers gently sublimate back into gas. It is a breathing of sorts, slow, vast, and deeply patient. Eris is a dwarf planet in the scattered disk, and it is actually slightly more massive than Pluto. It orbits the Sun on a long, tilted path that carries it far beyond the Kuiper belt, out into even more remote regions of the solar system. Eris is covered in a bright, reflective coat of frozen methane, giving it a pale, almost mirror-like surface. It is a quiet world, distant and unhurried, moving through the outermost reaches of everything. Makemake and Haumea are two other dwarf planets residing in the Kuiper belt, beyond the orbit of Neptune. Makemake is a reddish, frozen world covered in methane and ethane ices, orbiting in quiet solitude. Haumea is stranger still, a dense, rocky body wrapped in a thin shell of crystalline water ice. Both worlds are small and remote, part of that vast, slowly turning family of icy bodies that populates the outer edge of our solar system. Haumea rotates so rapidly that it has been stretched into an elongated egg-like shape. It completes a full rotation in just under 4 hours, one of the fastest rotations of any large object in the solar system. That extraordinary spin has pulled its equator outward, giving it a form unlike any other world we know. It is an oddly beautiful thing to imagine, a small, icy egg tumbling slowly through the dark, far beyond Neptune, unhurried in its orbit even as it spins. The Kuiper belt extends from about 30 to 50 astronomical units from the Sun, a broad, gently curving band of icy bodies that lies just beyond the orbit of Neptune. It is home to countless frozen objects, comets, dwarf planets, and ancient remnants of the solar system's formation. Though vast in area, the Kuiper belt is surprisingly sparse. Its objects are spread across an enormous volume of space, drifting in slow, quiet orbits, rarely disturbing one another. Far beyond even the Kuiper belt lies the Oort cloud, a vast spherical shell of icy bodies that surrounds the entire solar system at an almost incomprehensible distance. Scientists believe it extends from roughly 2,000 to as far as 100,000 astronomical units from the Sun. It is the most remote region of our solar system, a quiet reservoir of ancient ice and rock, gently holding the outermost boundary of everything the Sun has ever touched. Our solar system is about 4.6 billion years old, born from a vast cloud of gas and dust that slowly collapsed under its own gravity. From that ancient swirling cloud came the Sun, the planets, the moons, the asteroids, and every frozen body at the edge of everything. 4.6 billion years of turning, drifting, and settling into the quiet, ordered beauty we see today. It is an age so deep, and still it asks nothing of us but wonder. All planets orbit the Sun in the same direction, counterclockwise when viewed from above Earth's North Pole. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, each one moving along its own wide, gentle path, all turning the same way, like a slow and ancient wheel. This shared direction, is a memory of the spinning cloud of gas and dust from which they were all born, carrying forward that original, quiet rotation across 4.6 billion years. And so the solar system turns, together, in peace.